Hello everyone. In this video, you'll learn more about convection. At the end of this video, you should be able to describe, in terms of density changes, convection in liquid or gas. Before we start on convection, let us recall what you have learned for lower secondary science. In general, objects expand when heated and contract when cooled. When we say object expands, it means that the volume of the object increases. When we say object contracts, it means that the volume of the object decreases. The mass of the object remains unchanged during the heating or cooling process because the amount of matter the object has is still the same. If there were 1 million molecules in the object at the start of the heating process, there will still be 1 million molecules at the end of the heating process. Since density equals to mass over volume, the density of the object decreases when heated and increases when cooled. In other words, the object becomes less dense when heated and more dense when cooled. Convection is the transfer of thermal energy by means of convection currents in a fluid due to a difference in density. So, what are fluids? Fluid is a substance that flows. Liquid and gas flow, so they are considered as fluids. However, solids do not flow, and so they are not considered as fluids. Please take note that convection only occurs in liquids or gases, but not in solids. To demonstrate convection in a liquid, a few purple crystals of potassium permanganate are dropped into a flask filled with water. The crystal will sink to the bottom of the flask. The flask is then gently heated just below the crystals. You will then observe that purple streak of water will rise upwards and then fan outwards. The circulation of water in this manner is called as convection current. So, how is convection current formed? The water at the bottom of the flask is then heated up due to the fire. It expands, becomes less dense than the surrounding water, and thus moves upwards to the top of the flask. Cooler and denser water at the top moves downwards to replace the hot water that moves up, because the water level in the flask remains unchanged. The cooler water, which is now at the bottom of the flask, in turn gets heated up by the fire and rises, resulting in a continuous convection current in the water, as shown by the animation in the slide. What is the effect of convection? At the start, only the water at the bottom of the flask is hot. This is because water is a poor thermal conductor, and so thermal energy will take a long time to be conducted to the top of the flask. At the end, every part of the water is hot, including the top part. Before we move on to the next video, please look at the learning objective again. Are you able to describe convection in liquid or gas by talking about how the densities of the liquids or gases change when they get heated? That's all for convection. See you in the next video.